Okay, Year 8. So this is the Unit 10 quiz on investigating angles. Question 1. In each diagram, find the value of x and give a reason for your answer. So you must give the reason to kind of get the full credit here. So in this first one, x equals 125 degrees. And the reason is that they are corresponding angles. Corresponding angles. This next one, x is going to equal 180 minus 105, which equals 75 degrees, because these are co-interior angles. Co-interior angles. You could also say that this is 75 degrees by virtue of being two angles on a straight line, and then that is an alternate angle with x. The co-interior gets you there in one step. Remember, a lot of these rules kind of derive from each other. So then x, in this last one, x equals 57 degrees, simply because they are alternate angles. And we're only really applying one rule at a time there, so the explanations are fairly simple, but you do need to give them to show your understanding of the distinct rules. Question 2, find the value of x. You must give reasons for your answers. So let's work our way across a little bit. So this angle is going to be 180 degrees, take 134, so that will be 46 degrees. Now this triangle here is an isosceles triangle. Those two sides are the same length, which means that these two angles are the same as each other. Okay, if I mark that angle as y. So if I do 180 minus my 46, so that's going to give me the 134, because it's just kind of the inverse of that operation there. And then 134 divided by 2, which I make as 77 degrees, is that right? 130 would be... No, I don't make it 77. Make it 67. 67 degrees. So 120 would be 60 times 2 plus another 14, which is 7 times 2, so 67 degrees. So that's what each of these are. I'm going to draw those on now. This angle here is going to be 46 because it's co-interior. And then I've got 180 minus 46 because it's co-interior with the original 134, minus 67, which is angles in isosceles triangle. So that's going to equal 134 minus 67. So 2, 7, 0, 12, take 6, 6. Make that another 67 degrees. So x equals 67 degrees. Oh yes, actually, you wouldn't. So there was a couple of ways of getting there. So I've got x as 67. Similarly, when I found out the angles in the isosceles triangle, if I do this in green now, this one is alternating with x. So I could have gone straight there. So again, there are usually multiple ways across the diagram, but I think that's come out quite nicely. So question 3. A regular polygon has 18 sides. What is the size of each interior angle? So if I just draw a section of a polygon here, the interior angle is this guy, and it's regular, so they're all the same. And we had a formula for this. Now, you might remember the formula as n minus 2 times 180. If you weren't, so that is the, and then divided by n. So this is then this is kind of the sum of all the angles, and then divided by n gives you each angle. So if I've got 18 minus 2 times 180 over 18. Now what I notice is that I've got 180 on the top and 18 on the bottom. So I'm just going to cancel these out and end up with 18 minus 2 times 10, 16 times 10, 160 degrees. So my 18 sides, that's probably why this was chosen, has come out quite neatly, 160 degrees for each interior angle. And that's using this formula. that you kind of need to remember. If you're struggling to remember that, if you remember that all three angles in a triangle equals 180, generally I think people can remember that quite easily. That is 180 times 1. Well, it's a three-sided shape, so it's 180 times 3 minus 1, and that kind of is then your formula. No, 1 minus 2, sorry. 1 is 3 minus 2. So then that might help you remember that it's n minus 2 times 180 for the sum. And then obviously if they're all the same, then you just divide it by the number of angles there are to get the per angle formula. Right, question 4. Are AB and DC parallel? You must explain your answer. So if A, B and DC are parallel, then the angles, and I'll use my angle notation here, we've seen in the module, BAC and ACD will be co-interior. Okay, which means thus they will sum to 180 degrees. So let's check that out. 72 plus 108, and I can just see that that's going to kind of come out nicely. They do. So yes, they are parallel. If summing these two angles came up to anything other than 180, then they wouldn't be parallel because they wouldn't be obeying the rules of co-interior angles. Question 5. Shown below is a regular polygon. Find the size of the angle y. So I've got 1, 2, 3, 4, 5 sides. So the interior angles are, if you've got, it's going to be the same thing, n minus 2 times 180. So 5, I'm going to substitute that in, 5 minus 2 times 180, so 3 times 180, which is 0, 8 times 3 is 24, 1 times 3 is 3, 540. So, and then 540 divided by my 5, it's going to give me 108 degrees for each of these angles, right? So these are all 108. 108. And then this combined one is 108, and this is 108. These are the same size as each other. This is an isosceles triangle at the top here. And so that angle y is going to be 180 minus the 108, which is the kind of odd angle out here, divided by 2. So that's going to be 72 over 2, which I make 36 degrees. So we're combining our knowledge of interior angles with our knowledge of angles in a triangle to come up with that answer, 36 degrees.